Hello everyone and welcome. So we will continue on our little environment, and the plan for today I'm not sure yet, but we will tackle these hanging vines and also do some procedural rocks, and if we have time we might move this scene into Solaris, let's see. So yeah, let's get into it. Alright, I just saved a new scene from where we left, the last thing we did was to scatter some trees. I'm going up a bit and let's move this down. And also move this part a bit down. So let's move all of these and get some space in here. So the first thing we're going to do are those hanging vines. Let's object merge where was I? So I actually need to move this down. Oops. And move this in here. And let's object merge this null in here that is already remeshed, so we can take advantage of that. But still the resolution is not too much, so I'm gonna remesh it a bit, and the goal is to scatter some points in here in this part of the bridge and then generate the vine from there. So I'm going to remesh this again, so remesh to grid. I'm not sure if this is labs or not, and we're going to do 0.02, and I believe I didn't change anything else, and I'm just going to clip it along the z-axis. So clip along Z and by 3, -3. So we just have the front part, as you can see. I could have clipped it before, but now that I have the same density, I'm not gonna change it. So now we have the curve for the start of the bridge, and we can use that curve to transfer an attribute to this geometry. We could easily paint it manually, but what we will learn if we do that, right? So let's instead go the hard way and merge in the curve. Where is that? Let's see, curve. It's right here. So let's select this and go in there. Where is? Right here. All right. So now that we have the curve, we need actually to match size it so it is on this side. Let me see what sort of values I used in here. So I'm going to match size. Let's see. And we don't want anything along the X and along the Y. So none. And we do mean in here or center, sorry, center. So we have it right in the center. It will be easy to transfer the attribute from. And let's see. So it's right there. Now we're going to sweep it, so we just have a bit of geometry. So let's go with sweep. It will be easier to transfer the attribute. So we will do ribbon and a width of 0.09. Let me see if that is the value I used. Yes. So the thing is, we can create an attribute and do an attribute transfer, but since I want to do some operations in Vex, I will do everything in Vex, but you don't need to. So you don't have to Vex everything, but as a learning experience, it might be useful if you learn the hard way. So for the mask, we can use a simple PCOpen function. So let's do that. Let's create the handle. So it will be an int, and we do PCOpen, and we will look for input 1. So the sweep geometry, the position, and the current position, and we will define a radius. And let's say we search for 10 points, and we'll do f at mask. It will be equal to pcnum found, and the handle, and let's say if it's bigger than 0. Let's see how that looks. So mask, and it doesn't look like much, does it? Because I've done something. Oh, I need to define the radius, of course. And the radius, you can, let's see, we can start to introduce a radius. In this case, I use the radius of 0.115, so something like that. But in this case, as you can see, I'm also getting the mask in here, and I don't want that. I just want in this middle part. Well, this is a particular look I'm after. You might go just with this and be fine. So in this case, I'm gonna use the dot product from the normal and an up vector to remove some of the parts of this mask. So let's do that. Let's do float, and I'm gonna be creative and call it dots, and do dot between the normal and an up vector. In this case, I'm gonna set it to -1, and let's say if that is bigger. In this case, I want it right here, if that is bigger than 0.5. And we can just say f at mask multiply equals to dot. And that does that. Why have I done that? Now I wonder if that part is anything important, because that doesn't seem to change much. Well, let's see if now let's remove these parts in here actually. So let's do, I was hoping that that would get rid of some of the value in here. So as you can see, it's removing some, but it's not that important actually. Let's see if we change this to 0.1. So 0.9, oops, 0.9. And yeah, that starts to get rid of some of the parts that are not along the y vector. But in this case, as you can see, it's not that important. So, but now we can remove these extra parts we don't want, these extra bits. So let's do f at mask will multiply equals to a ramp. Ramps are always a great way to control these attributes. So let's do relative point bounding box, and we will do the incoming geometry, the current position, and the x. In this case, we want the x axis. And let's go in here and change this to ill. And now we can start to remove those parts. And in this case, I didn't use, I used linear, and I'm gonna introduce some values in here. So, oh my god, let's see. We can introduce this sort of values, and I can be picky about it, but let's see. This one is fine at the middle, then I want 2 in here, so this is fine. So I guess this is fine. Let's see if that dot product is changing anything, and it doesn't, but let's leave it there. So sorry about that. I just didn't review the file and didn't, maybe I was trying something different at that moment. But yeah, let's ignore that and keep going. So now we will do a scatter on that mask attribute. So let's scatter, and we will scatter on the mask, and we will do only 35 and change the seed. I'm gonna pick 19, but we can change that. And now I did a peak in here because I don't want the roots of the vines to be showing exactly at that part, so I'm gonna pick it a little bit. Let's see if we have normals. We do, so we will pick, and we will not recompute the normals because we might need them, and we will do -0.05, just pick it a bit in. And what else do we have here? This is always a surprise to me because I didn't review this. So let's do an attribute wrangle, and we will set the normals along the Z to be flat, otherwise the vines will go in these sort of random directions. At least that's... So let's do normal.z, it will be equals to 0.0. And as you can see, it will flatten out those normals along the Z. Let's see, let's move this down a bit, we need a bit more space. And we will create an all in here. I don't name it, but you can do your naming and be organized. And now we will create the vines. Again, I will be using simple tree tools. So trunk maker. And I'm gonna connect these in here. So let's do add spare input and connect these in here just to know that this is related. this node is connected, and let's also connect it to the seed points. Yes. So what sort of things we will change in here? So first of all, going to trunk, I'm gonna change the segments to 40 to have a bit more resolution, the length to 0.5, and randomize it quite a bit, and change the seed. And for the width, so the width, I'm gonna set it to 0.014, so quite small, and randomize it also. So now I'm just picking random numbers. And let's go with the seed. Let's see if I change anything else in here. No, I think that's fine. Now let's go to modifiers and apply some noise. So let's go with noise, and I'm gonna change it to noise 2.0 and reduce the amplitude. Change the size of the noise also to 0.6, and we could possibly play with the offset. Let's see, like this one. And I believe that's all for this step. Now let's move into tropism and play with the gravity. So in this case, I'm gonna set it to 2, so it goes like that. And that's fine. And let's also introduce some chaos. So in the chaos, let's introduce 0.375. Oops, what have I done? Let's 0.375. So some chaos. And we could possibly change the seed. And we can go in here and change the seed of these. Let's say I like this one. Now we just need to do trunk measure. No, tree measure. I'm still getting used to this. We could probably have tried to do this with labs tree tools, but I'm not sure about that because I haven't played much with it. I just think this is a good deal, this sort of tools. They are very, very versatile. So in this case, we can change here the profile. Let's do heal, and that will be flat. And now it's hard to see, so let's change the background. Am I recording? Yes. Let's change the background. Now it's too light, dear God, but that's fine. Let's create a name. And I also need to do this for the rest of the assets, but we'll do that in a bit. So let's create binds. And I guess we can merge this over and see if this doesn't crash, because I've been having some crashes lately. So that's fine. Let's disable the mask, and we could probably clean those attributes. And as you can see, it's not looking half bad. I think it adds a bit to the overall environment, and it will look nice with the fog and everything. So that's this part done. So now we will do the rocks. And ignore me if I go a bit slow, because I haven't looked into this file in a while, so this might go a bit slow. But let's do another geometry container and call it rocks, and we can color these, let's say this color, which is always nice. And let's dive in. The first thing, we will do a basic Voronoi fracture to get some rock shapes, and then do some volume noises to distort a bit the shape. This is very basic, but that's what we can do at this time frame, let's say, to not spend too much time on it. So let's create a platonic and change it to dodecahedron. Did I say that correctly? I'm not sure. So now we will do an ISO. Let's gather some points inside. So we'll do an ISO offset, and I believe I changed the resolution to 50, so the uniform to have more resolution. And let's do a scatter. And I just did a few, so 7. I want only 7 rocks. So let's change this to dark again. And now we can do a simple Voronoi fracture. So Voronoi fracture. Let's connect the inputs. Let's do an exploded view. And these will be our rock shapes. So what am I doing now? I'm going to move them to the 0, 0 position, so to the center. So for that I'm gonna pack, and we have in here a name attribute, as you can see, which will be useful to move them to the center. So we'll do just this trick, pack them, and as you can see in here, if you can see that, it might be too small, but we have 7 points or 7 prims, and now we can just do a wrangle, and on the packed prims we can do v at v equals to 0, and they will be moved all to the center instead of doing a for each loop. We will do a for each loop anyways, but anyways. So now we can unpack, and let me see, I believe I need to move the name attribute, or does it have already? So it transfers, we don't need to transfer it again. And we will do a for each named primitive. Where is that? For each named primitive. And let's see, as you can see, we're iterating through all of them. We can do a single pass for now. And we will do a basic, very basic edge damage. So I'm going to remesh, just like we did for the bridge. So let's remesh, and in this case I use the value of 0.2, that's fine. Attribute blur, you know the deal. And the attribute blur is also default. In this case I'm going to increase the iterations to 2. And I'm going to do a mountain. Let's move this a bit. And the mountain, let's see what sort of values did I use. So an amplitude of 0.19, and of course we need a positive offset. And I also changed the element size, so to point, I'm going to try to get the same results. Let's see if that works. But you can easily play with these values. And well, now let's do a Boolean intersect. And you can see we start to get these sort of results, which are nice. Let's see the others. So this rock shape, I guess this is fine. But you can possibly play with the scatter seeds and get different results, as you can see. And it will be pretty fast since these operations are sheep. Now, we will do we'll add some basic details using VDBs. So we need to remesh this. So let's do a remesh. And I'm gonna change this to 0.02. That is fine. And let me see, I have an attribute in here that I'm not sure I'm going to use. Let me see that. Do I use that attribute? So I have a mask in here. Yeah, I'm not using, so we will just do a VDB from polygons. VDB from polygons. Let's see, I'm gonna use quite a low resolution. I'm gonna increase it, but for now let's keep it like that. And let's say we want an exterior band of 0.3, so we can have more exterior voxels. And fill interior, that's fine. Now we will do convert VDB and convert this to polygons so we can preview the final result. And let's do a volume vote. And I'm going to go through this I need to change, since this is binding to density, it's always better to change this to density. If it's fog, it's already density, but we can do that for SDFs too. So we don't have to bind, export to surface and whatnot, or do a volume sample. So let's go through this quickly. Basically, we create a static noise. We will fit the values, so fit range, we will multiply constant to control the effect, and let's connect all of these, and we add it at the end. So we add it to the current density. And we need to get the position to the position, and let's do a frequency, create a constant, middle click, create a constant, and do a multiply constant so we can increase the frequency of the noise, so change the size of the noise. And yeah, am I connecting these? So why is not doing anything? No. So let's change this in here to 10, and it's not doing anything. Oh, because I'm not connecting to the value. Now it's doing something. Let's change this multiply constant to 0.055 so we start to see the results. And in this case, I'm gonna use a frequency of 3, not 10. And I'm also going to change the noise type because this one is pretty boring. So we will do Worldly Cellular F to F1 and change the offset to 80. That's the value I had going. And I'm also going to add some fractal, but to the position. And First of all, we want to play with the source min, so we just get this sort of holes on the rocks. So I'm going with a value of 1.1, something like this. And now I want to distort the position before it's connected to the noise, before it's sampling the noise. So I'm gonna do an add, a turbulent noise, connect the position to the position, and since we're going to distort the position, we need a 3D noise and we need a zero-centered noise. So in this case, I'm gonna use sparse convolution noise, which is sort of between -1 and 1, and connect this in here, and it will be too much by default. So in this case, I'm gonna change the amplitude to 0.35, so it is a bit less, and maybe play with the frequency, and we get this sort of nice result. At least I think it's a nice result. And if we increase this to 0.06, we start to get a bit more detail, as you can see. Alright, let's reduce this again to 0.1, and I believe I used yet another noise, so I'm gonna duplicate all of these. So hold Alt and drag down, and let's add this to the same input, the same output. And what did I change in here? So first of all, I'm gonna change the repetition to 2.5 and a multiply constant or a bit less, so 0.016. And we might just look at this noise without the other one so we see what we're doing. In this case, I didn't use a fit, I used an unclamped fit. So fit range unclamped. It's connecting or not? Okay. And I'm gonna use a value in here of 0.745. So we get this bulging effect. And I'm also having the turbulent noise. In this case, I'm gonna change this a bit to 0.43 and change the frequency to 1. So you just have to play around. So as you can see, this one doesn't look half bad, but I'm gonna change it to 1. And I believe I also changed the noise. Let me see. Yeah, I changed the noise in here to just F1 and play with the offset. So 170. We start to get this look. Let me actually see if that noise makes any sense. So in here I have that particular noise, but it's not adding much, is it? Or do I need to increase the resolution? I guess I need to increase the resolution. Let me see something in here. So 0.016, 0 and 1. Did I use the complement? Yeah, I used the complement in here. So it goes a bit in to create this whirly look, as you can see. So that is fine. Let's connect this in here and connect this one in here. And I guess this is fine. Let's just change the resolution to 0.06. Go until your PC starts to scream. So as you can see, nothing too special, but we get some nice details, and at render time we will also add some displacement, so it will be a bit better, I guess. Let me change again this. So in this case, what we will do next? Now we will need the name attribute again. We could transfer, but let's just do an attribute wrangle and create the meta import node. So this will give us a value of each iteration. As you can see in here, we have iteration, and we connect this in here. And we can change this to primitives and say I at class, it will be equal to detail 1 iteration. And that will just give us a class attribute that we can use later. And the thing is, now we need a low poly version also, so a proxy version of this. And since for loops don't give us two outputs, we can merge them in and then split them after the loop. So for that, I'm gonna just create a dot in here, and we will name and we will name this to iPoly, I believe. So rock, what is that? Rock iPoly, and let's do in here rock low poly, and we will do a poly reduce. In this case, we will do it quite a bit, so poly reduce, and we will reduce it. We will just keep 5%. So this doesn't matter, it's just a low poly version to act as a proxy, so we won't render this. And now we can do a merge and connect this in here. So, damn it. Sorry about that. So we'll do a merge. And I guess this is fine. We can just compile this if it works at all. So let's do compile. Oops. Compile block. Let's connect this in here. It's connected, yeah. And let's not forget to change this to multi-threaded. Let's see if that takes too long. Let's see. So 2, 3, and it has to calculate the VDBs and do the poly reduce. So it's already done. That's fine. And we will do a file cache. So I haven't looked at the results of all the rocks, but that's fine. So let's do rocks cache demo. And we don't need time dependent, we will just do save to disk a single frame. And now we can split the iPoly. And let's do a no and another no, and change this to out rocks iPoly, and do out rocks low poly. Okay. We could possibly do a blast and do its name. Oops, we can do in here. So at class is equal to 0 and do points and delete non-selected. So at class is not points, sorry, is primitives. And we can look at our result. Let's see the other ones. And I guess this will work fine. As you can see, nothing special, but I don't like my... it's okay. Nothing special. We could probably change the offset of the noise to have more variation, but let's not worry too much about that. So yeah, that's our rocks done. So now, just to finish it off and have the scene ready for Solaris, we're going to do some basic fog. So we have our rocks taken care of. So let's do a geo and name it fog. And just for fun, just change the color. And we will need to dive in here and let's see, we can create a null in here and copy the path, Control C. Let's go to the fog and object merge and paste. So we have the bounds of our geometry and we can actually, my mistake, we need to connect this in here. So we have everything. We could possibly get rid of the trees. Did I connect? Let me see. Did I connect the plane also? I believe I need also to connect the plane. Where did I do that? So in this case, I also need to connect the plane. So let's do a merge. And we will do in here, we will connect in here, and we will also add a name. So that's fine. Let's copy. We already have copied, so let's go to the fog and we have an object merge. Let's create a bound and that will be fine. Alright, I didn't change anything in the bound, just default settings. And now let's do a VDB from polygons. We will create some fog because I'm not a particular fan of the fall off of the fog in Solaris. What is it called? Fog, Karma Fog Box, I believe. So I'm gonna do my own, so VDB from polygons. At least in my tests it didn't look that good, so I'm gonna create a density fog and create a 0.05 and do a basic volume up. And in here we will start with the relative bounding box. So yeah, let's do relative point bounding box, relative bounding box. We can possibly connect the position And let's do a vector to float to get, in this case, we want to get the Z axis. Let's connect that to density. And as you can see, it starts to fall off based on the position we have, but we need actually to fit it a bit. So fit range. And we can start to play with the values. So, but first of all, I want, so we are in here, and I want less fog on the front. So let's do a complement to invert the results. And as you can see, we start to lose some volume in here. And I have some values. I'm gonna play with the source mean, so 0.295, so it removes some of that, but I don't want to completely remove it, so I'm gonna add some value to the low bound. So 0.13, as you can see, we can change that, and that will be fine. And we also could multiply constant this to about 0.3, so it has a bit more density, less density, I mean. Now, this is looking quite boring, so we could possibly introduce some noise right here when we are sampling the position. So let's do a turbulent noise, and I'm gonna change this to 3D noise and sparse convolution, connect the position, and let's change the frequency to 0.6 and the offset to 100. These are some values I played with, quite a big amplitude, and also some roughness. And let's connect this and see the results. So let's add and connect it in here. So we start to get this sort of results, but I want to play a bit with the attenuation, so something like that, and maybe do some more turbulence. The detail of this noise, this fog won't be really seen with everything happening, but we just have it there, so it will be seen somehow, but not this much detail as you can see right here. So we could possibly play with the offset, as you can see, and we start to have a different result. And if we change the amplitude as well, as you can see, let's change that to 5, and that's fine. Let's see how everything comes together. So now we might do the scattering of the trees, the rocks, so we can compose everything at the end and have a nice result. Let's see. I have in here. Did I use the rocks in here? So we have the trees, and we do have the rocks in here. So let's go above, right where we have this, and let's do an object merge. And let's look for those rocks. So rocks out, we can do low poly for now. And let me see, out rocks. I believe I forgot to add an output in here, so let's create a null on the rocks geometry and connect this and call it out rocks, and copy this so we can switch between high and low poly easily. So let's go to the geometry and paste this in here, and now let's do a blast. And in this case we can keep the low poly since we're going to do a basic scattering in here. So let me see. In this case we will do another object merge, and we need to merge in here the terrain. So where is that? Let's see, terrain. So I don't have a null. I need to check where it is now. So after the in here, so let's create a null and call it out the terrain, copy, and where was I? In here. So let's paste it in here. So we want to scatter some rocks right on the edges or on this simple lake. So let's do that. So we will need a scatter, and we will scatter on the river mask, so scatter, and I'm gonna scatter just a few, so 24, and I'm gonna scatter on that river mask that we have, so that's fine. Let's see, and we will change the global seed. I have a value in here, but we might need to play with it, and of course remove the relax iterations. Let's see, I might need to play with this seed. All right, let's do a connectivity in here. And I guess points will be fine on the points. And we will have a different class for each rock. Let's do an attribute from pieces. Because if we copy the points, let me just check that out. Let's make sure we pack. If we copy 2 points, it will copy all the rocks at the same time. So we need to do an attribute from pieces, and let's name it class, and we will pick randomly, and we can play with the seed in a bit. So let's do this, and now in here we can pick a piece attribute and go with class, and now we can play here with the seed. So for now, let's see, we might need to play with these seeds. And let's do first of all an attribute that just float for the p scale, or in this case I use the attribute randomize, and we will randomize the p scale and change this to 1 since it's a float. And let's see what sort of values did I use in here. So in this case I changed this to custom ramp and played in here. So let's do b-spline, and I played with these values, and I don't want them so small, so I just want some big and most of them to be small, so I'm not going to be too picky about it. And let's do an attribute that just float to change the overall effect. So in this case we can just do multiply, so constant multiply, and we can change the size. Let's change this to 1.3. Oops, not to 1. And the thing is, now we can change this, and I'm not sure why it's changing the seed. It should be the same rocks, but I guess it has something to do with this connectivity in here. So yeah, let's see. Yeah, so we can keep this the low poly, and let's do a merge and see if this doesn't crash. I just saved it just in case. And let's merge it. And let me see, this is getting too much on this side. Let me check that river attribute. So I guess we could have played with it, but honestly I'm just going to play with the seed. So let's see, and I'm not going to worry too much. Let's keep it like this, and we can change this to the high poly, and we start to see the results of our efforts. And we can probably change here the seed also. I like that one. So I don't like this one. So you can play with it until you find a nice result. Let's keep it like this for now. We could probably create also a camera. So let's save just in case, and we can look at the final results. So, and now let's also go in here and change this fog and introduce the geometry. And this is starting to get a bit slow, but you can see where we're going with this. So honestly, I'm gonna leave it here, and in the next part we can start to focus on the Solaris setup and materials, and we will move the scattering systems to Solaris, which will be pretty easy. And yeah, if you would like to have the files of this scene, you can do so by signing up to my Patreon. And you can also find exclusive tutorials in there, hours of exclusive step-by-step tutorials, and also some courses and all the scene files from my videos. So yeah, let me know in the comments what you think, and I hope you are enjoying this one, and I'll catch you in the next one. Thank you.